Welcome on this presentation on technical work done on a recycling container in Tanzania. And for your information, this session is being recorded and we will publish it afterwards on our webpage. So by participating, you are giving your consent to that. We will have time for questions and answers at the end. Or if you have questions during the presentation, feel free to raise your little hand in Teams or to send a message in the chat function. So this assignment has been in collaboration with our long-term partner NITO and local project partner Tanzania Explorer, who is here represented by Sondre today. Engineers Without Borders has supported the initiative to set up a small-scale plastic recycling container in Dar es Salaam. And in the beginning of 2022, we had two volunteer engineers on assignment, David and Jon Anders. They partly built and installed machines for shredding, extruding, and injection molding. And this was in support of and in parallel to an innovation contest for NITO student members. And that report has already been published on our webpage. In January this year, NITO launched a new innovation competition for engineering students with the challenge based on the existing machinery or with feasible upgrades given available time and resources, develop products made from recycled plastic that can be sold locally. And in March this year, Arnfinn and Marius, whom you will hear from shortly, they spent 2 weeks on assignment in Dar es Salaam, optimizing existing machinery and also mentoring the winning team of NITO students during the project execution. So first, welcome Sondre. He will give a brief background and context of the project before we give the word over to Marius and Arnfinn. Vær så god, Sondre.
My name is Sondre Astøl, and in this session I'm representing the local facilitator, Tanzania Explorer. And I'm going to give a brief background about the project, and then we're going to start to talk about NITO's involvement, the NITO Innovation Contest, and this year's contest, which was a follow-up of the first contest we had in 2022. Just one slide first with Tanzania Explorer, the local facilitator. Whoops, sorry, went a little bit too fast there. We are a safari provider, but we also work a lot with local projects, community projects, and we have an acronym called SURE, which basically represents those elements of local engagements that we are involved in. So we support local sports team. We're building wells on Zanzibar. We help with educational material to schools, and we also work a lot on recycling. Our biggest problem as a provider of safari is that we have water bottles. We produce a waste of more than 10,000 water bottles per year. And this is how we kind of got drawn into the environment issue to see how can we reduce our plastic waste. So that was the very beginning in 2016. And then we have a local beach. The picture that you see now is a picture of Mbongoland Beach outside of Dar es Salaam. It is actually a very beautiful beach, but as you can see, it's not particularly beautiful in this picture. And that is because we have a lot of waste coming in, plastic waste from the Indian Ocean, and primarily this is local waste. The problem, however, is not the plastic, and the problem is not the waste on the beach. The main problem and how we can solve the waste problem in the ocean is basically through changing mindsets. And we know that when it comes to this project, we're not going to be able to save the world. We're not going to be able to save even our own beach, but hopefully we can spark interest and raise awareness about the real issue in the ocean, which is microplastic. So in 2017, we bought a small little container that was basically a waste container in Dar es Salaam. And this was the start of this project. Then in 2018, we entered an agreement with NITO, Norwegian Engineer and Technology Organization, as well as Engineers Without Borders. And this was the very beginning of this project. And when we launched this project, we thought about how is the best way for us to actually reach out to the next generation. And NITO then come up with a great idea to have an innovation contest towards their students, the engineer students and tech students in Norway. And this was the very beginning. So in 2020, we started right before COVID with this project. For natural reasons, this was postponed. And then in 2021, we started the first NITO innovation contest in Norway. I'm going to show you a small little video from the very beginning. This was the recycling container when Engineers Without Borders was there for the first time. And they were basically building the inventory of the container at the same time as the NITO students were innovating new ideas on what we could actually produce in this container. So in March 2022, we had the first group of NITO students down into the container who started an innovation process. They were there for 10 days, doing a lot of really, really cool innovation, both related to 3D printing of PET plastic, and also through some of the extruder machines that Arnfinn and Marius will talk about a little bit later. This was a huge success. And then in December 2022, we started this year's contest. And that was also a collaboration between NITO, Tanzania Explorer, Engineers Without Borders, as well as Trygg, which is the insurance partner of NITO. And there were 9 teams who competed in this competition and come up with the best solutions on how to take the next step in this container. And the winning team was from NTNU in Trondheim, and they had a very, very cool idea about using sheet press to produce small recycled boards and then creating gutters from those plastic, how do you call it, sheets. I'm going to show you a couple of pictures from the project, but Marius and Arnfinn will go more into detail as they can explain things in a better way than I can in terms of the technical aspect. But in short, it was a really, really nice week. If I can ask everybody to just mute, that would be perfect because we have a little bit of background noise here. So if everybody's on mute, that's perfect. So this is a picture from the innovation that actually took place in Tanzania just 2 months ago. And as you can see from the picture in the bottom left corner, the first product was not exactly the best one. But this is all about innovation. You have to do a lot of tries. And I can show you the first sheet here that was pressed, used from the sheet press. Not exactly perfect, but this was the final result. And these can now be produced into different kind of usable products locally in Tanzania. A couple more pictures here from the different kind of designs that the team innovated. And I'm going to now set you over to Arnfinn and Marius, who can talk about the technical details about the products, how the students came up with these products, and also the use for the different kind of plastics that we find on our beach. So Arnfinn and Marius, you are up.
Thank you so much for the introduction, Sandra. I will try to share my screen now. Let's see if... Can you see my presentation?
Perfect.
Very good. Okay, before I dig into the project details, I would like to start off talking 2 minutes about what is plastic and why it's so important for our modern society. Because I think that plastic has had a much more positive contribution to the world than the problem it has caused. And I just want to mention 3 quick examples. Within health technology, plastic had made it possible to produce affordable and sterile medical equipment. And that has been extremely important for healthcare and quality of life around the world. Also, energy efficiency. Plastic is the key technology in both production of clean energy and also reduced consumption due to better ways of insulation, the material, lightweight components for transport means, and things like that, which again has reduced the greenhouse gas emission. And number 3 is agriculture and food production. So plastic have enabled the development of more effective and sustainable ways of doing agriculture, for example, drip irrigation, and also better way of improving food preservation and make it possible to ship food over a long distance around the world. So I think it has been extremely important also in food security. So this is important to keep in mind. But of course, unfortunately, it comes with a disadvantage. And when plastic ends up in the nature, and especially in the ocean, it's often lethal to the marine life. Fish and birds can get entangled into it, and some animals, including the turtle that you see here, can mistake plastic waste for food. And the main challenges with plastic as a material is that it doesn't decompose. It just breaks into smaller particles. This is often referred to as microplastics and nanoplastics. And these particles can even end up in our food chain. There is a lot of research going on regarding plastic in the food chain, and I don't think we see the full extent of the problem. But we do know that it has many negative health effects. One of them is being reduced fertility, and of course this applies to both animals and to humans. And I think we can agree that we definitely need to do something about reducing the amount of plastic in the nature and in the ocean. One other big challenge with plastic is that it is difficult to recycle. And much of this is related to the melting point. If you recycle, for example, glass or metal, you heat it up to a very high temperature, for example, 1500 degrees for glass and more than 800 for most of the scrap metal. This process is purifying the material. Well, plastic has a very low melting point, and some plastic types even starts to melt below the boiling point of water. And it is not being purified by the remelting process like glass and metal. And using a too high temperature on the plastic will degenerate the plastic even further. And this process may also release toxic gases. So that's a challenge. And finally, a big challenge is that you cannot mix different types of plastic in the recycling process. This is both due to that they have the different melting points, but also different mechanical properties. So this makes sorting process challenging. I just want to show this figure. I'm not going to go into detail on it, but I want to keep it in the presentation as a reference. The main thing here is that we do produce 270 million tons of plastic every year. And 8 million of those tons are ending up in the ocean every year. So this is a huge problem that we are solving. And as Sandra said, the real reason to start solving this is to create awareness. And that takes us to Tanzania. And I want to mention on Tanzania, this country has actually done a lot of effort regarding plastic pollution. In 2019, plastic bags were banned in Tanzania, and you're not even allowed to bring any plastic bags into the country. They have a special desk at the airport for travelers where they can surrender their plastic bags. And also several areas in Tanzania have introduced a recycling scheme for the transparent bottles, such as water bottles. And of course, these things have made a great positive impact on the environment, but there are still a lot of plastic pollution, and we need to create more awareness around this problem. And as Sandra mentioned, this is the main reason for this whole project. And of course, we have created a lot of awareness amongst the students in Norway. This student competition that Sandra mentioned has been a worldwide competition in Norway. And also the students in Tanzania has been visiting this plastic recycling container. So then going into the project and the equipment. The first week, me and Marius came to Dar es Salaam. The main goal was to inspect the existing equipment and fix it, improve it, and do some maintenance. And the main equipment that was already there was shredder, extruder, and injection mold. The machine that you can see here to the left is the shredder. And that machine basically cuts the plastic items into small flakes. And these flakes can be melted and used in the other equipment. The machine in the middle, that is an extruder. And the extruder basically consists of three main parts. It's a hopper where you put the plastic flakes that you made in the shredder. You have a barrel with heaters and a turning screw. This is used to melt and compress the plastic. And finally, it has an extruder nozzle where you get a constant flow of melted plastic. So this machine can either be used to make a continuous profile, such as a beam or tube, or the plastic can be extruded into a mold. And then the machine that you can see to the right, that is an injection mold. And this one also have a hopper where you put the shredded plastic. It has a barrel with heater, similar to the extruder, but instead of a turning screw, it has a piston. And finally, it has a nozzle. So in this machine, you put a specific volume of shredded plastic, and then you use the piston to compress the melted plastic into a mold. So here on these pictures, you can see the main team that was there. We have Veronica Donald, who is also joining us on the Teams meeting today. She works for a Tanzania Explorer, and she is the manager for the recycling container. And then we have Marius Hagen and myself. So we started our work familiarizing with equipment and also doing some required maintenance. And we realized that some of the equipment was not in a great condition. So we spent some time getting it to work effectively. There was a lot of rust and some of the parts were not working. And these machines are based on the Precious Plastic movement. And Precious Plastic, that is an open source organization that provides free drawings and design for the various machines. And most of the parts are based on standard equipment. But despite this, it's very difficult to get the proper components for the machines in Tanzania. And as you can see on the last photo here, we are out on the local markets and trying to find some parts that we needed to repair the equipment. So that was some of the challenge, but we managed to get all the equipment up and working and tested it and did some samples with it. On the second week we were there, then the NITO students from the competition arrived. And as Sandra said, they had purchased a sheet press that would be used in their suggested solution. And a sheet press is basically consisting of two parts. It's an upper and lower plate with heaters, and it has a hydraulic jack that is used to press the two plates towards each other. So then you put shredded plastic in a frame between the two plates. You heat it and you use the jack to compress the melted plastic into plastic sheet. Then I just want to mention how this was actually shipped to Tanzania, because that was a challenge. We bought this from a company associated with Precious Plastic in India. And then it was shipped to Norway. It was disassembled in Norway and taken to Tanzania in the students' carry-on luggage. And you may ask, why was it done like this? Why not ship it directly from India to Tanzania? And the reason for this is that it's actually more expensive to ship directly from India to Tanzania, despite the shorter distance. But the main problem is that the customs in Tanzania is extremely slow and bureaucratic, and the machine would probably have been stuck in the customs for many weeks. And also we would have to pay a high fee to get it released from customs. And that also explains some of the challenge in getting getting equipment into some of the African countries. And now I want to give the control to Marius. Will take over the presentation and go even a little bit further into the technical aspects and the challenges of the project.
Yeah, the press was in kind of poor condition on arrival. We had to use a lot of time getting it up and running in a satisfactory manner. We used a couple of days to assemble it, to get all of the sensor working perfectly. We had an issue with the hydraulic what should I call it? Check at the bottom there. It wouldn't compress the plate properly, and after a while it stopped working. So after we replaced it, it worked better. And we also had some issues with the heating element, which was too weak. We had to add isolation material to the press to get it working. Without isolation, it stopped at 200 degrees, and we needed to get it up to 260. But with isolation, we managed to get it up to 280, so that worked properly. The students also added a wood chipper, as you can see in the middle there. This is perfect for granulating the materials. The original shredder that we had in Tanzania could only shred like 2 kilos per hour, but with this cutter we managed to shred 8 kilos. So it was a huge improvement. See if I can change picture. Yeah. So as you can see here, most of the plastic around is this blue bottles. These bottles are made of PET, and our main goal was to try to use PET because that was most of the plastic. And our plan was to Arnfinn, can I go back one?
Oh yeah.
Yeah. And our main and our plan was to collect this plastic and wash it, then shred it into a granulate for easier processing, and then make plates that we could press into gutters. And that went, well, could have went better. The first plate we made had kind of the same mechanical properties as a biscuit. They were quite stiff, but really weak. We also tried extruding the PET to see if that worked, but then we had an issue with the low viscosity. The viscosity of the plastic melt was similar to water, and we had a huge problem with air bubbles. I worked a bit with plastic, and this was kind of strange behavior. So I did a small literature study of the plastic and become quite clear why this was happening. Apparently, if you have moisture present with the plastic, when you're heating it, you get something called hydrolytic thermal degradation. And to explain why this is bad for you, bad for the plastic, I have to explain how plastic works. Usually, plastic are made of long molecular chains that are made out of repeating units. And the longer these chains are, the stronger the plastic. And when you have water present, you will this water will react with the molecular change and start cutting it into smaller chains. So you get poorer and poorer quality. And this reaction speeds up as you heat it. So when we were heating it up to 260 degrees with water, we destroy the quality of the plastic. Also, while extruding the plastic, while in the extruder, it didn't have so much time to degrade. But when you have water added to plastic, the water acts as a plasticizer and makes the attraction force between the molecular chains weaker, so the plastic flows easily. So if you want to use PET, you have to dry it. In the industries, it's recommended to dry it to 0.02% of moisture content. Yeah. Luckily, there's other types of plastics that you also can use. These are the plates that Sondre showed you earlier, and they are made of HDPE. And HDPE is quite easy material to use. It has a low melting point, around 130 degrees, and it has a wide processing windows. And PE is quite simple, molecular, so it doesn't care about other things like water and oxygen. So it won't degrade that easily. The only issue is that it can be a bit difficult to obtain, or like it's not that much present. Most of what we used was made from bottle caps and shampoo bottles that we managed to find. Yeah. Well, our biggest challenges with this was getting the sheet press to actually work and to work properly. We used a lot of time with that, and working with PET. That could be a quite difficult plastic to work with. We learned quite fast. Also, finding correct parts and equipment in Tanzania could be a bit of a challenge, as Arnfinn said earlier. It makes that, yeah, this made sure that everything took a bit longer than it should. Yeah, something to add, Arnfinn?
No, I think those are the main challenges, and yeah. But as you mentioned, especially this thing with getting the sheet press and setting that up with all the poor quality and replacing the jack, installing the temperature sensors. They were not installed when we got it. Electrical cable was not installed. It was not very well documented from the supplier. So we had a lot of challenges with that. And yeah, as you said, the PET material is very difficult to work with. And yeah, so I think these are the main challenges that we experienced.
Yeah. So recommending, if you're gonna try to use PET, you have to dry it. In the industry, it's normal or the suppliers of PET normally advise you to dry it for 6 to 8 hours at 120 degrees. So trying to dry it properly or as cheap as possible should be a priority. And yeah, extruding PET does seem to work quite nice. So that could be a easy way to use a lot of PET to make either beams or other profiles. And also the washing section used a lot of time and manual labor, so getting an automated system to wash the plastic would save a lot of time and money. So yeah, that's most of it, I think.
Yes.
Yes, any questions?
Okay, thank you so much. Very good to hear from all of you. I can see there is a hand raised, and that would be Petter. So if you unmute yourself, Petter.
Yes, not to be confused with a pet, but I'm Petter. I'm group lead in Engineer Without Borders. One question, but first, good presentation and good work, guys. Thank you. The selected team was proposing this sheet press. In fact, was that not needed? Could we have managed without it and just used extruder and extruded directly into these plates, or is a sheet press, was that strictly needed?
It could, if you only wanted to make gutters, it could have worked. But with the sheet press, if it was a calculated risk, because if you couldn't make the gutters, you at least had a plate that could be used for other purposes.
Yeah. Also, one challenge with extruding directly into the mold for a gutter is that the mold would probably be quite large, and you could at least it would need to be a heated mold probably, because otherwise, sorry.
Yeah, or conditioned mold. Sorry.
Yeah, or a conditioned mold. Yeah, because otherwise it will start to solidify before you have filled the whole mold. So it's also about the size of the part.
Okay. Thank you.
Thank you, guys. Do we have any other questions? Feel free to raise your hands or write in the chat. Sondre, go ahead. Oh, you had your hand raised, maybe.
Yes.
Sorry.
Just a follow-up also to Petter with regards to, if we look at it from the competition side, from the students, in their paper that they handed in with the proposed suggestion of doing the gutter, they were also very aware of having a plan B if the gutter didn't work out. And after day 4, that's what they found out. They had to switch to plan B. And like Arnfinn said, now having that sheet press, and basically now it's producing perfect plates that can easily be changed into other products. So it made the whole innovation process for the student also easier, because they were able to change the final product and actually get a goal out of the week. Because if they put all the money into the gutter and that didn't work, they basically were left with nothing. So that was also big credit to the students who had a plan B that they could pursue when they met obstacles.
Thank you, Sondre.
Yes.
Sagalo, I saw your hand was raised. I can't hear you. Still nothing. If all else fails, you can also write in the chat. Try one more time.
I had one chance to visit a facility, like rely on the.
Sorry, Sagalo. It's not possible to hear what you're saying. Do you want to write your? I don't know. You hear me, right? Yeah. It's just we can't hear you.
Let me type.
Type in the chat. That's perfect. In the meantime, we have another question. So from Francisco, how challenging is it to separate the different types of plastic, and to which degree does the purity, or to what degree, and to which degree the purity of plastic needs to be? To what degree do the purity of plastic need to be? Yes, got there in the end.
Yeah, it was somewhat challenging. We were the bottle caps should have been HDPE, and they were marked HDPE, but no, some of them was polypropylene instead. They have changed the plastic, but not changed the tooling. So normally you can see the marking if it's a 1 or a 5, so it's easy to recognize. But when you can't what can I say, trust that marking, then it's hard. So we had to test it by either floating or burning or other methods, and it's quite important to have the correct purity. Plastic is complicated, and mixing different kind of plastic, you may quickly get different or encounter a lot of problems.
Yeah, and there is a requirement that all plastic should be marked, as Mario said, but unfortunately it's not being done in real life. And also, yeah, as you said, Mario, the marking are sometimes wrong. So it's frustrating, and it's a very big challenge. Veronica, you have a question?
Please go ahead, Veronica. You have to unmute yourself first.
Hello, can you hear me?
Yes.
Okay, thank you so much for the good presentations. And I'm Veronica from Tanzania Explorer. I would like to ask, because in the recommendation, Marius presented that he recommended that we have to dry the PET at 120 centigrade between 6 to 8 hours. But now we dry the PET in the sun. So I'm a bit confused how we can make sure we dry them at using 120 centigrade, or we have to use the that in order to dry the PET, or just the sun. If we use the sun, how can we be sure that it is completely, it is at 120 centigrade that we are going to use it and make it dry for 6 to 8 hours? Did you get me?
Yeah, it was a bit unclear, but I think I heard what you said. Trying to dry it, it's quite tough. In the industry, we use a huge container that is sealed, and we pump hot air at 120 degrees. So that works kind of well, and it gives us usually a quite consistent moisture content. But getting it, yeah, we need to do it a bit cheaper. We can't do it on an industrial scale. So that's something we have to consider what is available. But we need a sealed container so we don't get any more moisture. So after we dried material, we should let it stay dry so it couldn't have any moisture getting in. Just didn't, yeah.
There's definitely enough challenges with working with PET. And Veronica, please follow up on email.
Yeah, I can.
Yeah.
Probably easier to do it on email.
I will. So Sagalo wrote in the chat, and I think mainly I'll direct this to you, Sondre. Congratulations for the great job has been done. I had a chance to visit the facility. Would you mind working with people based in Dar es Salaam? Because it seemed the operation rely on availability of students from NITO Innovation Contest.
That is 100% correct, Sagalo. Because the students from NITO was basically the ignition in collaboration with Engineers Without Borders. So everything, the development of the container going forward will be done 100% in Dar es Salaam. So, and Veronica is in charge of the project. So anybody who is interested in joining in, Veronica will be the main contact person from us. So 100% big yes there.
Thank you. I see we have another hand raised, Bahati. Let's hope the network is on our side.
Yeah, thank you for the presentation. I think you guys have done very, very good work, and
it's somewhat not on our side today, I think.
The network fell out again.
The network. Bahati, can you hear me? The sound just stopped all of a sudden, so we can't actually hear anything. So Sondre just said before the meeting that Teams is not his favorite channel, and in terms of not fantastic bandwidth, then yeah, it's hard to disagree.
yeah, I went off. I'm not sure if I still have time to talk, or it is now time for another person.
You are back. Please continue.
Oh yeah, I was saying I've seen what you are doing. I visited your container, and actually Marianne has also been inviting me to meet her personally. Unfortunately, we have been actually missing each other because of the timing. What I would like to say is that we currently finished our phase 1 project of cleanup, which is also funded by Norwegian Retailers Environment Fund. And what we saw across the country was that the bottles, which Marius said, the black one, which are not recyclable easily, was still a big problem to wherever we went. And I was thinking maybe there's a need for us to look into the possibility of working together, because we have phase 2 of the project, which starts around August this year. And we have invited the funders, the HMF, the Norwegian funders who funded this project of cleanup. Actually, we are doing cleanup in not along the coast. We have shifted our focus to across African Great Lakes, Lake Victoria, Tanganyika, and the Nyasa, which they are all in Tanzania. And actually, that's where the economy of fisheries is dominated. So we get more income in Tanzania from freshwater than the marine. So we have actually tried to invite the funder to come, and I was thinking if we can actually see the way of collaborating your organization and our organization, and actually present to the funder that we are willing to work together. Because one of the issues which we saw is that almost 300 people have already demonstrated interest of joining recycling from at low scale or at small scale. And I think with your knowledge and the knowledge of Zagaro actually comes from Arena Recycling, and he was part of the team training people in recycling. So I think let's find a way of synergizing our effort, and probably these funders, if we convince them with your model and what we are doing, probably might get another funding to expand recycling knowledge across African Great Lakes. That was just my comment from my side. Thanks. So I did not introduce myself, actually. My name is Bahati Mayoma. I'm from the University of Dar es Salaam. I'm currently based in Cape Town, where I'm starting my PhD in plastic pollution. So I'm still playing that game again. So let's hope we'll be joining force together. Thanks.
Thank you, Bahati. And yeah, you have our emails, and I believe you said you were going to send one regarding this, and thank you for bringing it up here. It's definitely interesting. I think I can see Sondre is clapping, and yeah, it's definitely interesting for all parties and in all our interests to collaborate further. Do we have a question in the chat? We have two, it seems. So from Amina, This is a good thing for the sustainable management of plastic pollution globally. Regarding the products produced from reused plastics, microplastics in parentheses, have you tried to check on the leaching of these microplastics from the products after being exposed to the harsh weather conditions? Thank you, Amina, for very good questions. I'm not sure who has a very good answer. I'll point to Marius, who is the main plastic expert. To what extent would microplastics, leaching of microplastics, to what extent might that be an issue? Is there any certain knowledge on that?
Yeah, there's a lot of what can I say, research done at that point, and that depends completely on the type of plastic we're talking about here. So like if it's PVC, it's quite dangerous. It's quite what can I say, harmful for most beings. And yeah.
HDPE or PET?
HDPE is not that what can I say, harmful. It's kind of harmful, but not the worst one. PVC is kind of the worst of the worst. And then it also depends on if you add some plasticizers. A lot of the plasticizers that adds are quite harmful for humans. Also, if you add something to, what can I say, to reduce the flammability of the plastic, that is also almost always harmful for humans. So it depends on a lot of factors, and it need to be quite specific, actually, to get a good answer there.
And do you have a comment, Sondre?
Yeah, I would say, like, on the general level, it's also a responsibility that we have, or whoever is producing products from recycled material, to make sure that whatever product that is put out back on the market is tested, as you said. Because let's say we would produce dining plates or things that would be in touch with food, then special caution needs to be taken, and special measurements needs to be taken to ensure that that doesn't affect the food that we're eating. So I think it's a very important question, especially for those who actually produce their products, and that they were aware of the problems that could arise if we produce plastic plates, etc., and then give it back to the market, because that could be very harmful. So it's a very good question, and something that anybody who recycles products needs to be aware of if it's supposed to be in contact with food or directly to the human skin, for instance. So very good question.
Do you have a follow-up question, Amina, or was or answered? Or feel free to jump in if you want to follow up.
I'm satisfied, thank you. But because a lot of people normally ask, what happens if we introduce these things back to the environment? Because you're breaking the plastics to microplastics, then to nanoplastics. So we are reducing the sizes. So it means you're exposing this back to leach to the environment. When it rains, what happens? When it's being heated by the sun, what happens to these microplastics? So it's something which we need to take action in before introducing these products back to the market.
Thank you.
Absolutely.
So I'll go by order here. Is it question from Francisco? Is it possible to separate the types of plastic by chemical testing, similarly to what is done with other substances, that one drops a reactive substance, and depending on the results of the reaction, one determines whether the substance tested is as expected or not? Could something like this be possible with the different types of plastic?
Yeah, it's chemical. Yeah, it's probably easier to just look at the other properties. Chemical testing is quite complex. It could, if you have something had some foreign substances mixed with the plastic, then it could interfere. But the best way is to usually check for the density by floating or weighing the plastic, change for the look at the melting point, and look at other types of properties. Chemical testing is complicated. It's of course possible. You can go all the way up to spectrometry and different thermal testing. You can use complicated machines, but doing this on a huge scale out in the field, it's of course possible.
It's always a balance. So what is the best adapted to the surroundings that we're in than in small scale projects?
Yeah.
Big scale solutions it's too complicated and too expensive.
And budget has something to do with it.
So from Sagalo, I would like to advise that it's possible to locally fabricate a washing unit from experience I had from Plastiki Rafiki, Kenya. This can be done by using scrapper washing machine and a small motor pedal. That is great input. Have you guys been in touch about this already?
We have looked a little bit into it, and we have looked into Plastiki Rafiki in Kenya, and that looks very promising. They are, I think it's a quite early phase company or a startup, but it looks like they are running, in a serious way and starting to do good business and becoming a supplier with a good reputation. So what I'm hoping is that can be a supplier for future containers, for future plastic recycling units in the area, in Tanzania and in Kenya. So as I mentioned, now we had to ship some equipment from India to Tanzania. It's very complicated. We would absolutely prefer to have a local supplier.
Absolutely. Have you been in touch with the Plastiki Rafiki Sondre before, or Veronica?
Me not directly, but I know about them. I know that Veronica's had some communication with them as well. So I think this is what it's all about. It's about basically uniting small, different and fragmented initiatives everywhere to make sure that there's a dialogue and a constant dialogue, so that if there's 20 different small projects, that they're not have to do all the innovation themselves. So doing a collaboration like that is vital, I think, to also spread the mindset and to make sure that sharing ideas is the proper way to actually get somewhere.
Thanks. 100% agree, of course. And Sagalo, I will send you a follow-up email to get further contact details. I do believe that we have also in another project heard about Plastiki Rafiki in Kenya, actually, in another completely separate discussion. So I'll follow up on that one and share. Comment from Amina. I would like to advise having these machines distributed all over Tanzania districts so as to promote the recycling rate of the plastic waste around the country. I think we can safely say we all share that common interest. Thank you. So we are approaching the end here. We do have a few minutes left. If there are other questions or comments.
Yeah, I have just to remind you, I think Zagaro, would you please share the link of the project which you have been doing in the African Great Lakes, so that our colleagues can also follow us I think you might be able to see what we are doing from the social media, because we normally post a lot of stuff, including what type of plastic we get and, you know, the expectations of the people and something like that. So I thought maybe it would be also good for you as the team to actually know what we are doing. So Zagaro, please put the links, the LinkedIn and the Insta. We're actually developing a website from the Norwegian side. Our partners in Norway are preparing that website. I think once it's launched, we can also share with you so that you know what's going on for possible future collaboration. That's all from my side.
Thank you, Bahiti. There is the Instagram for Clean Shore Great Lakes. Fantastic. The final report from Marius and Arnfinn will be published within the latest 3 weeks time. So the draft is it's almost ready, and then it will also be available on our webpage, and I will share the links on the reports that we do have that are all in English as well. Okay, so thank you all for participating. Thank you so much, Arnfinn and Marius and Sondre. And very good to see so many people. Thank you for now.